Yeah. Okay, so welcome to this particular tutorial on effect of force or stress on a material. So in this particular tutorial, we'll be looking at importing a particular um, material. In this case, it's a bone. I want to see the effect of force on it. Okay, so let's get right into it. All right, so here is the COMSOL, and after which we are going to click on Model Wizard. Okay, so in this particular case, we are considering the 3D dimension. So you click on 3D. All right, then we move on to select physics. In this case, we'll be going to structural mechanics. Move down. We're interested in solid mechanics. All right, we add. So this will help us to study the effect of force on a particular material. All right, then the next thing is we click on study, and then we are going to be considering time dependence. So click on time dependence and then done. So wait for it to load. All right, so as you can see, we have the X, Y, and Z dimensions. Okay, now in this particular case, we are going to import a particular file. So this file was saved as .dsf. So right here in Home, move on to Imports, click on Imports. All right, then you click on Browse. So you should have a particular folder where your work is saved or whatever you want to import, where you can easily get it. Okay, so you click on Class Sample and then you open, after which you click on Import. All right, so here is the material that we want to study the effects of force on. It's more like it's a bone, okay? It's 3D dimension structure or model of a bone. All right, so the next thing we're going to do is we want to select the material, like the kind of material that we are calling this model. So to do that, we move on to, we have material under component here, or if you want, you can move on to material right up here. Okay, so if you go up here, click on add material. All right, then under what you have on the right, far right, you have add material, and then you search for, you go to bioheats and then bone. All right. Move on to add to components. Okay. So we've added that to the components. Now, as you can see here, under the settings here, we do not have the value for the Young's modulus, likewise the Poisson's ratio for bone. So you're going to go on Google to check for, now in this case, we are considering the adult femur bone. So when you are going to check for this, ensure that you're particular about the publication. Make sure it is a recent publication, not something that is a far publication, and it should be from a verifiable source. All right, so in this particular instance, we are going to be using the Young's modulus as 18,600 megapascal. So here we have PA. That PA stands for Pascal. So what we're going to put is 18600. Now we do not need to put the comma, all right? And then megapascal. Now ensure that you're careful with this. You put the square bracket, then capital M, capital P, A, and then you close the bracket. Take note of the type of brackets that we are referring to here. All right, then for the percent ratio, we're going to make it 0.3. So this also, you check it on Google to be sure of what it is. Okay, so every other thing has been said there, and as you can see, it has been ticked. All right, so the next thing we're going to move on to is we want to set, now this is the material in particular. This is the model, and we're looking at it as a bone. Now, we're going to select, we want to get a point, we want to get the particular region that will be fixed. Okay, we're going to have a fixed point, and we're going to have another point where I would say is not fixed, which is, I would say it's free. All right, so to do that, move on to solid mechanics here, then you right click. When you right click, look for fixed constraint. Here it is. You click on it, and now, as you can see, we have to select. Meanwhile, we can close this particular add material so that we can have enough space. Okay, so we have to select some parts in this model. And then, as you can see, this is already on active mode. So we want to select the parts that we do not want to move once we are applying a particular force. So in this case, when you hover over the material, for example, if I click on this, you can see that indicates that that is 1. So let us assume that we do not want this bottom to be moved. We want it to be fixed. That means that this other end, that's the other end to the right, will be fixed. Okay, then we want to select this particular point, which is 2. You can just twist, you can move your model. How do you do that? You just click on outside here, you left click, and then you move the cursor. So like that, in order to have access to other sides that is hidden. So we click on this. All right, so we've clicked on 1, 2, 5. So we are saying that this ends, okay, those ends will be fixed in this particular study. All right, so that's done. The next thing we are going to do is we right click on, so we want to select the other side, which will not be fixed. Okay, so I will say that's a free end. So we right click on solid mechanics. All right. Now let's say before we go to the free, let's go to this boundary load. Okay, let's go to this boundary load. Okay, now under the boundary load, we want the load to be on one particular side of this model. We want the load to be on a particular side of this model. So that's the load of the force. So now it's not going to be here because that's a fixed point. So we take it out, click on it and take it out. All right, then let's turn it. So let's say we want the load to be on 18. That's the other end of the material. So okay, and then we move to go to force. Okay. Under this force, okay, we have user defined. Okay, good. We're going to select total force. Select total force. And then under total force, we have X, Y, and Z. We want the force applied only in the x-axis, in the x-axis. So we're going to turn that to 10,000, and then we're going to put the units. Now, this is already in Newton, but we want it as 10,000 kilonewton. So put our square bracket open, then K is capital and N is capital, and then you close the square brackets. So, okay. Now take note that when you make mistake in these simple brackets, it may have issues with computing. So you need to watch carefully. All right. So the next thing we do is now let's go to let's right click on okay. Okay, let's right click on the solid material one more time, and then the free, let's go to the free. Okay, now which parts do we want to be free? Now for the free parts, let's see, we have manual here. Okay, enough, we have a free one here, so we do not need to take this particular step. So you can delete it. Okay, so as you can see, I just right click. Okay, when you right click on that free, you can click on delete. So we've successfully deleted it. So let's look at the free. Okay, so as you can see, we have 1, 2, 5, and 18 are overridden, meaning that you have you have overwritten, like you have certain function on those sides, on those 1, 2, 5, and 18. The other sides are free. Okay. So the next thing we do is, I think that's pretty basically what we need to do. Then we move on to a mesh. Now, do not forget that for this particular mesh, um, now for this tutorial, we're going to go with extremely coarse because we want it to we want to get our results right here and now. So it's going to be faster, but for proper projects, you use the extremely fine or extra fine. All right, so click on extremely coarse, and then you build. So we're going to see, so that's what it's going to look like. That's extremely coarse. And then the next thing is move on to our time dependent. Just click on it. And then we're going to select the time, because this is a time dependent study. It's not a stationary one. Okay, so this is 0, then 0 0.1 and 1. So we're going to change 0 0.1, change to 5. We change the ordinary 1 to 10. Okay, as you can see here. All right, so I think that's basically all we need to do. Then we can compute. So let's see, I hope it's going to compute fast and in order to see the effects. Okay. So click on compute. You can check out can check the progress, over here. Can move it up, move it up, and then you can see the brain linear system moving. Okay, so let's be patient for a while. Okay, so it's on 5%, and okay, so what I'm going to do is I'm going to show you what it's going to look like, because um I want us to be time conscious. So now just leave it and go and do other things, in as much as you know that your system will not go to sleep or something like that. So um, now I'll just so I'm still on 5%. Okay, so let me show you what's going to look like. Let me show you a project that has been done and then show you what it's supposed to look like. So let me stop this particular one and then I'm going to show you what it's supposed to look like. Okay, so it's because we stopped this. Now I'm going to run it afterwards. So here is what it's supposed to look like. Let me see this. Okay, okay, good. So now, after it has completed, it's going to look something like this. All right? Okay, this is one. Now, if you look at what does all this mean? This particular graph shows that this place is kind of is red, and then it's the color changes from red to orange, yellow, up to blue. So the part where you have red shows where you have much the much force. Okay, so you're gonna have more force on these bends. That's what it actually means. And as you can see, now you can still look at it more. You see that along this region, this place is looking like it's blue, it's bluer than the other end. And this end is um, um okay. So you just need to be able to understand the results that we have here.